Section 9.5 War, Sports, and Tigers. Counting tanks. During World War II, Allied forces wanted to know how many tanks the Nazi army had. After capturing numerous tanks, the Allied forces realized they were numbered 1, 2, 3, and so on and so forth. They wanted to know roughly how many tanks the Nazis had given the serial numbers on the tanks that they had captured. They came up with 5 methods. Method 1 and 2 are based on the idea that the center of the sample should be close to the center of the entire population. Method 1 is finding the mean of the numbers, then doubling it and subtracting 1. Method 2 is finding the median, then double it and subtract 1. Methods 3 and 4. Methods 3 and 4 are intended to avoid the problems encountered with methods 1 and 2. These methods will give you a bigger number than the actual. Method 3 involves getting the average of the highest and lowest numbers of your sample size, then doubling it and subtracting 1. Method 4 involves assuming that you have captured the last possible tank produced, in which case your estimate would be the highest possible number. Method 5 is the last method and is the most refined and will give you the best estimate. Method 5 involves taking the maximum number of tanks and multiplying it by k plus 1 divided by k minus 1, and k is equal to the number of tanks that you have captured. Counting tank problem. In this problem, you have captured tanks with the following serial numbers: 46, 75, 35, 109, 82, 112, and 57. Using the 5 methods, calculate roughly how many tanks the Nazis have. Using the methods that we talked about earlier, you would get, using method 1, 147, method 2, 149, method 3, 146, method 4, 112, and method 5, 127. Next, we'll talk about genetics and how Mendel used statistical methods to understand how genes move from generation to generation. In his research, he used green and yellow pods for his experiment and discovered how genes travel through generations. In his experiments, the gene sequences for a pure green plant was PG and PG. In a pure yellow plant, the gene sequence was PY and PY. And in a second generation green, the gene sequence was pure green and pure yellow. In a second generation, where you're using 2 second gen pea pods, the chances of it being a green pod are 3/4 and a yellow pod 1/4. So suppose you have a red snapdragon plant and a white snapdragon plant. Each has 2 genes. A red one is red and a red, and white is a white and a white. These are known as parent genes, and when you combine one parent gene with the other, you get pink. Pink equals red plus white. What are the possible outcomes if a red and white snapdragon crossbreed? There are 4 possible outcomes. The first being that red and red make a red and a white make a pink, a white and a white make a white, and a white and a red make a pink. So there's a 1/4 chance of it being red, a 1/4 chance of it being white, and a 1/2 chance of it being pink.